So I will present the fraud detection on credit card transaction using machine learning. So it's Python, sorry, no Java for this few minutes. Also, why I use credit, it's because with credit we have more fraud rates. It's more interesting for the fraudster than the poor debit card, so it's easier. But let's see. So about the fraud, just to put the context here, my work was done for, I followed the training by Sintra here not in this side, but the other building, the Entrepôt Royal, but I don't know how we call this in English. And then the person responsible of the training asked me to use what I do at work. So we try to use what we have learned. So here I only will speak about the fraud at the issuing part, meaning that you have a card, you pay on in the restaurant, in the store, whatever, online. So it's this part. For the fraud detection in general, by my company Worldline, I won't present it, but I let it on the slide. We also do the fraud on acquiring side, meaning what arrive at the merchant online, if they have to accept the order or not, or if they suspect money laundering and so on. But it's simple here. So it was also the reason why I choose this part. I also try to simplify the thing. I use supervised learning because luckily from my work we receive what we call we receive from the card scheme Visa, MasterCard if the transactions are fraudulent or genuine. A few days, a few weeks later than of course. But if I go 1 month in the past, I'm quite sure that I have enough label to train the model. If I try the transaction of today, no way. It's too early. So it's supervised learning. It's quite simple. I don't speak about other things like anomaly detection and so on when it's more complex. So the goal was to simplify the problem. Big problem I've had, and I still have for this presentation, is which data I can use. So in Kaggle you see an example quite old without any explanation, use again and again and again, and it's not really convincing. Luckily, during the last day for the presentation by Sintra, and internally I can use the data from Worldline because it was for presentation done inside the company. But here I have quite a problem. So luckily there is a kind of old project. It's between 5 and 10 years. And it's kind of to create a fake transaction and to create some fraud patterns. And it's, I would say, enough for this evening and for the preparation I've done. About the fraud detection, and we are in the imbalance data. So I have only a few fraudulent transactions and a lot of genuine. It means that the supervised learning with the machine learning, which works fine when you have balanced data, when it's imbalanced but little it's okay. With extreme imbalance data, it's work not very good. So the example, you have this imbalance ratio. So the majority class on the minority class. So I took some example in the literature. I have still the book somewhere here, if you want. And usually, this value is bigger than 1. It's 3, 4, 10, 50. Here, with the credit, the fraud on the credit card, 800, it's not, it's even more than that. So this is the problem, the severe imbalanced data. Another problem that I've had, I took a very old document, a paper done more than 10 or 15 years ago from a colleague who has already left the company. The problem is transaction alone, the data of the transaction alone is not enough to detect. So you put the transaction without doing anything. You try the machine learning with Python, and after a while you realize that it doesn't work. Because we need some aggregate to see what was the behavior of the cardholder to see if it's fraudulent or not. So meaning that if you are a guy who do a lot of things online, buy a lot of things online, you pay something online, it's normal. Your grandma who doesn't use its credit card online and just pay at the store or in the restaurant, suddenly if she do 3, 4, 5 things buying online, it's strange. So we need a kind of memory, some aggregate to enrich the data and to make the machine learning working. So now, just to explain the algorithm that I will present, I decide to use very simple algorithm that that won't take too much time. So the first thing is a decision tree. It's quite simple. It takes the variable and try to, by condition, to select on one side the fraudulent transaction and on the other side the genuine transaction. Then it's quickly not enough. Then you have other algorithms that combine trees. So the one thing, the bagging is you put a lot of trees in parallel, and after that you have the result, and the system try to decide if it's fraudulent or not. And the boosting, now the trees are not in parallel but sequential. So then you have the example of the trees. So I don't know if red is fraudulent. I suppose that red, because there is more that is genuine, and blue fraudulent. So the idea of the bagging, have a lot of trees, but in parallel, and then I collect the result and I decide what the system decide if it's fraudulent or not. But it may not work correctly for the fraud detection. Boosting, now the trees are sequential, but it means that you imagine the time for the learning. So it's a problem when the algorithm becomes more and more complex, it takes more and more time. So now, I guess I will try to, oh, nothing. My beautiful Jupyter notebooks. So the beginning it was just the import of the library, all the preparation. Then for this simulate data, the first thing you have the transaction. It's quite simple. You have an amount. You have the flag if it's fraudulent or not. You have some fraud scenario. So this column will be removed. Otherwise, it's simple. If you have a fraud scenario, it means that it's fraudulent. So you have to pay attention that after that, you have to remove some column. So here it's the transaction, the raw transaction. Then you have a work to add some aggregate, meaning, for example, how many amount the card holder have done during the last 30 days and so on. It's really something that we do at work. Not in this way, but the idea is behind. So I took some example of just to show you the. So for the credit approval, we have normally it's here refused and here approved. Be careful, it's the opposite. But the imbalance is you have imbalance, but not extreme. Here with this diagram, you don't see anything. And so I can show you with the pie diagram. I know that people dislike that, but you see the difference. And sorry. Now a big problem also when you do the machine learning with extreme balance data, it's that you have to take the good metrics. And it can give you a very bad result. So usually the algorithm use the accuracy, but it's very a bad metrics for the fraud detection because I will use a dummy classifier. So here I put the most frequent. And then the result is UP, accuracy 0.9, and the maximum is 1. Oh, I have a perfect model, but a model which does nothing, because it put everything as not fraudulent, and then with accuracy code, the ratio, you do this value divided by this value plus this value, have a big, very big, a good result, but nothing. So it's really an open question. What is the good metrics to use? By default, when I work on this, I do the F score or F1 score, which is this complete complex formula, but you have a balance between the false positive, a good balance to measure the result with the imbalanced data. So if I do the thing with the naive Bayes, which is a very, very, very simple model, I try to have the result with the metrics. So I make a lot of mistakes. Here it's a mistake, here's the mistake. Here and here it's the good the transaction who are correctly selected. And the result here with the F1 score, it's 0.1. So I know this matrix is not so good, but it shows that this is a good matrix. The question of the metric could be complex because, in fact, for our work, we could have what is important is maybe the sum of the two, because we have some people answering on the phone, we have fraud detection, the cards are blocked, and next day we have a lot of people calling Worldline saying my card is blocked. Why? Is it? And we need enough people to answer to the phone. So maybe this F1 is not the best matrix, and we should invent something else. Voilà. Alors, I saw that I take more time that I expect. So I will show you the result with the simple tree. So you have two ways to, so each algorithm have a lot of parameters, and we have to find out what is the good hyperparameters. So you have two ways, or you try randomly. So here we will try 3 times random this four value, what is the best solution. And the other way, because the learning, the decision tree is quite quick, we could use another way to just say, with the grid, I will check all the possibilities and find out the solution. And at the end, I found the value here, and yes, I have play. Huh? So I have the best value, and I try to, with the validation data. And so here it's the, with the training data, the F1 was 0.8. The test data 0.7. Well, the difference is not so big. If the difference is big, and on one side you have 1 and then 0.5, it means that you have overfitting. Your model is bad, and you should restart again. And at the end, yes, here it's interesting, and it's shown that my model is not so good. You see the importance of the amount. And I know that by experience, if the model, the model explains the importance of each variable, and the amount so big, no, it takes the amount, it takes too attention on the amount. And usually what we do, it's to try to reduce to say the amount is low, medium, high, to avoid that. And usually the amount has not so much importance. The fraudsters are quite shy. So here it's, well, I have played because the red is the fraudulent transaction, blue the genuine, but I put more importance because I don't have so many fraudulent transactions. And you see that the difference is quite big. So behind each model, you have a label, but you have also the probability of the label is fraudulent or genuine. So you have always a score. And you took, in this diagram, the score, and you see if you have a big split, it's that your model is quite good. If it's mixed, it's a bad sign. So the last, the value of the matrix, that's it. So I go back to the presentation, but I have nothing to add, luckily. Wow. Sorry, I do this work I do this work 1 year ago. I have to stop. I restart it, and just my conclusion. The principle is simple, but when you want to work on it, it's very, very difficult. So, if you have any question, tell me. Sorry, I was too long.
Maybe we can have questions during the drink afterwards, so we can. Okay. Thank you. Thank you.